Hello everyone, I am Mary Evelyn P. Violago and my partner is Lian Maxine M. Venturina and we are presenting our paper, Assessment of Arsenic Net Concentration in the Water and Sediments of the Angat River Network in Banga and Plaridel, Bulacan. Water is essential for all life on Earth. Clean, fresh water is necessary for drinking and sanitation, providing for our crops, livestock, and industry, and creating and sustaining the ecosystems in which all life depends. However, in today's world, water has become a significant threat. As the world's population rises, development and industrialization rapidly become the primary cause of water contamination. Water contamination by heavy metals is a serious environmental hazard that adversely affects all creatures exposed to it, including humans, animals, and plants. Heavy metals are metals that are harmful at low concentrations and can have an impact on and threaten human health. Arsenic, chromium, copper, cadmium, mercury, lead, and nickel are some of the river's most prevalent heavy metals. The Angat River in the province of Bulacan comprises three dams: the Angat Dam, the Ipo Dam, which provides drinking water to Metro Manila residents, and the Bustos Dam, which feeds water to crop areas. The river has a basin area of 1,085 square kilometers and flows from the Sierra Madre Highlands to Manila Bay. Angat River surrounds 11 municipalities in the province of Bulacan, including Angat, Liwag, Bustos, Calumpit, Doña Remedios Trinidad, Hagonoy, Norzagaray, Paombong, Plaridel, Pulilan, and San Rafael. Based on the Water Quality Status Report for Region 3 from 2001 to 2005, heavy metals such as arsenic, cadmium, chromium, copper, iron, lead, manganese, mercury, and zinc are present in the Angat River and are within the ENR limits. However, this could have changed due to the rapid development of the area and the factors that affect the river throughout the years. There are multiple studies about the concentration of heavy metals of the Angat River. However, in this study, the heavy metals, specifically lead and arsenic, will be assessed in water and sediment samples from the Angat River, focusing only on Banga and Plaridel, thus concluding the study to be novel. The Angat River network in Plaridel, Bulacan is part of the Angat River's midstream. The river is bordered by agricultural, residential, transportation, and commercial establishments. There are also industrial establishments within Banga and the neighboring communities. The river also provides food and livelihood to the residents who live nearby. The waste emission from these operations may harm the river, aquatic species, and residents who rely on the river for a living. Upon ocular inspection of the area, the gray color of the water can be vividly seen, and the river banks are full of solid waste, especially in the residential sector. Therefore, the Angat River network's quality must be assessed in light of recent activities in Plaridel, Bulacan. The potential for the river to be contaminated with lead, arsenic, or any other heavy metal is a threat to aquatic species living in the river and the residents as well. The objective of the study is to determine whether the levels of lead and arsenic in water and sediment samples collected from the Angat River in Plaridel, Bulacan comply with the acceptable limits established by various organizations such as WHO, EPA, DENR, and WSRA. Furthermore, the result of this study was compared to the result of the Manila Water Company between 2001 and 2005 to examine if the concentration of these heavy metals has increased over the years. Also, the result of this study will serve as a preliminary assessment of the municipality regarding the toxicity level of the river due to lead and arsenic concentration. This will allow the local government to plan action if a need arises. The municipality was informed about the study and agreed that it would be shown to them upon getting the results. If the concentrations exceed the established limits, the municipality will be responsible for formulating and implementing the necessary actions to address the situation. The study scope and the limitations are outlined as follows. The collection and testing of water and sediment samples is limited to a single sampling point. Samples were gathered and tested once every month. The analysis only focused on lead and arsenic as heavy metals of interest. The upper and lower streams of the river were not considered as the study pertains only to the Plaridel network of the Angat River, which represents the middle stream section. Due to these scopes and limitations, the study's findings primarily apply to the area of the river where the samples were collected. The concentration of heavy metals can vary across different regions of the river, influenced by various factors and surroundings. Moreover, it is essential to note that this study will not encompass water quality monitoring parameters such as pH level, turbidity, temperature, dissolved oxygen, total dissolved solids, and total suspended solids. These aspects are beyond the scope of the current study.
The Angat River, the largest river in Bulacan, flows from the Sierra Madre mountain range to Manila Bay. Several dams are situated along the Angat River, namely the Angat Dam, Ipo Dam, and Bustos Dam. The Angat Dam alone provides a daily supply of 500 million gallons of water, meeting 97% of the water needs of Metro Manila. It also irrigates approximately 28,000 hectares of agricultural land in Bulacan and Pampanga provinces. The municipality of Plaridel, Bulacan consists of 19 barangays, namely Agnaya, Bagong Silang, Banga 1, Banga 2, Bintog, Bulihan, Culianin, Dampol, Lagundi, Lalangan, Lumang Bayan, Parulan, Poblasyon, Rueda, San Jose, Santa Ines, Santo Niño, Sipat, and Tabang. Due to the vast expanse of the Angat River, this study specifically focuses on the section of the river located in Barangay Banga 2, Plaridel, Bulacan. This section represents the middle stream and is chosen due to its convenient accessibility for sample collection. The researchers will focus on one sampling point in this section to gather water and sediment samples. According to its comprehensive land use plans, Banga 2 belongs to the identified central business district in Plaridel, which is why the area is surrounded by commercial and industrial establishments, agricultural, transportation, and residential areas. The river surroundings were considered when selecting the sampling point because numerous factors can contribute to the heavy metals in the river. All water and sediment samples collected from the river undergo testing at the FAST laboratories. Skilled technical experts specializing in testing and operational areas perform the testing procedures. The laboratory strictly follows internationally recognized testing methodologies and employs approved instrumentation. Additionally, it has been accredited and recognized by multiple government agencies. This research is an experimental study that involves quantitative data analysis. The study aims to assess the concentration of lead and arsenic present in water and sediments within the Angat River network, specifically in Banga 2, Plaridel, Bulacan. The analysis will use atomic absorption spectrometry and a colorimetric method. The study will span 3 months from January to March 2023, considering factors such as time, flow rate, weather conditions, and the surroundings of the sampling location. To collect the water sample, a polyethylene terephthalate bottle with a cap with a 1 liter volume was employed using the grab sampling method. A glove was worn before the collection of the water sample. Facing toward the direction of the water flow, the initial step involved rinsing the PET bottle. Removing the bottle cap, the container was inverted and submerged below the water surface, ensuring that at least 1/3 of the container volume was filled with river water. Gently shaking the container, the water was poured downstream from the collected sample. This rinsing process was repeated 3 times. To obtain the sample, the container was again submerged below the water surface until it was filled. The container was labeled with the date, time, and weather conditions, along with recording the water flow. For the sediment sample, a 4-liter polypropylene bucket pail and a stainless steel scoop were employed to collect sediment samples. While wearing a glove, grab samples of the sediment were scooped from the sampling point where the water sample was obtained. The container was labeled with the date, time, flow rates, sediments, and weather conditions. To preserve the quality of the samples, they were transported to FAST laboratory within 6 hours from the moment of collection under ambient temperature. This prompt transport was done to minimize the potential changes in the chemical parameters of the samples. Lead concentrations in the water and sediment samples were determined using 3111B direct air acetylene flame atomic absorption spectroscopy. The water sample underwent analysis for arsenic concentrations using the 3500 arsenic B method, specifically the silver diethyl dithiocarbamate method. This method is a calorimetric technique designed to determine arsenic in aqueous samples. As for the sediment sample, a modified colorimetric method was employed to analyze arsenic concentrations. During January and March, the wind was characterized as a light breeze and the weather was rainy 2 days before the sample gathering, followed by a sunny day during the sample collection. In February, the wind was described as a moderate breeze that may carry dust, leaves, and paper. The weather was rainy 2 days before the sample gathering, with a cloudy day during the sample collection. Accounting for wind is also essential as it can introduce airborne pollutants into the water. Ahmed T. et al. State that storm events, snowmelt, drought, and elevated air temperatures significantly impact drinking water quality. For example, heavy rainfall can increase water turbidity, while temperature changes can affect the chemical quality of water. Table 5 presents the test results concerning the water samples obtained from the Angat River in Barangay Banga 2, Plaridel, Bulacan. The results indicated that over 3 months, the lead concentration was less than 0.01 mg per liter, while the concentration of arsenic was less than 0.005 mg per liter. Notably, both heavy metals concentrations fall within the acceptable limits established by WHO and EPA or EPA for drinking water. Furthermore, these concentrations adhere to the allowable limits the DENR set for water quality criteria for Class BC concerning toxic and other deleterious substances in fresh waters. The concentration of the heavy metals, arsenic and lead, determined in the sediment samples collected from the Angat River are presented in Table 6. The arsenic concentrations were less than 0.005, 0.02, less than 0.01 mg per kilogram for January, February, and March respectively. Similarly, the concentrations of lead were less than 0.01, 0.04, less than 0.005 mg per kilogram for the corresponding months. Based on the results, the detectable levels of both heavy metals emerged in February, possibly influenced by the weather conditions and the ongoing construction near the sampling site, which started in February and stopped in March. Additionally, the results might be affected by the different sediment conditions. Numerous studies have looked at the relationship between sediment, grain size, and heavy metal content. The major finding is that metal concentration rises as grain size decreases. Nonetheless, the concentrations of both metals remain within the acceptable range established by the WHO and WSRA for sediment samples. For the conclusion, the study utilized atomic absorption spectroscopy and colorimetry to analyze the levels of lead and arsenic in the Angat River network located in Barangay Banga 2, Plaridel, Bulacan over 3 months. The findings indicate that the concentrations of lead and arsenic in the Angat River network in Plaridel, Bulacan are within the acceptable limits defined by various organizations such as WHO, EPA, DENR, and WSRA. Comparing these results with data collected by the Manila Water Company between 2001 and 2005, it can be concluded that despite the rapid urbanization and industrialization in this area, the concentrations of lead and arsenic have remained within permissible limits over the years. However, it is essential to note that the concentrations observed in this area of the Angat River might differ from the other parts. Therefore, it is recommended to conduct further testing to determine the levels of lead and arsenic in different sections of the Angat River. Furthermore, the results obtained from this study still fall within the classification established by the DENR for Class B and C freshwater and remain appropriate for activities involving direct contact with water, including swimming, and for the growth and propagation of fish and other aquatic resources. It can also be utilized for activities such as boating and specific manufacturing processes after applying appropriate treatment measures. The following recommendations are made for further study. Given that the Angat River serves as a vital water source for both humans and aquatic organisms, this research study suggests conducting tests on physiochemical and bacteriological parameters such as pH, turbidity, dissolved oxygen, biochemical oxygen demand, total suspended solids, total dissolved solids, and coliform count for a more comprehensive understanding of its overall water quality. To better understand the impact of weather variations, it is advisable to extend the study duration. This would allow for a more extensive examination of weather patterns in heavy metal concentrations. Since this study only conducted one trial per month, it is recommended that future studies increase the number of sampling trials for a more comparison of heavy metal concentrations in the Angat River. Furthermore, this study focused on a single sampling point, specifically Barangay Banga 2, Plaridel, Bulacan. Testing multiple sections of the Angat River is advisable to enhance understanding and obtain more accurate results. Surrounding factors may impact heavy metal concentrations in the river, and testing different areas would provide a more comprehensive picture of the overall water quality of the river. And that's the end of our presentation. Thank you all for your attention.